Ed Van Rens, member of the Infinity QS marketing team. I'd like to welcome you to today's webinar, A Primer in Quality Data Integration, as presented by Infinity QS Engineering Project Manager, Eric Weisbrod. Now, Eric has extensive experience with integrating plant systems and solving quality issues on the plant floor. We're all going to benefit from that experience today. Eric came to Infinity QS after serving several years in the electronics industry, but since joining the company, he's been crisscrossing the country and the world for that matter, solving issues for manufacturers in food and beverage, aerospace, auto, packaging, life sciences, consumer processed goods, energy, you name it. Because of that, he's a really valuable resource within Infinity QS. In fact, whenever I have a question about how something works or which piece is needed to hook into that system, one of my first calls always goes to Eric. Before I begin, I just want to get a few quick housekeeping notes out of the way. We'll be running about 40 to 45 minutes of the presentation, so plenty of time for Q&A after. You can go ahead and type any questions throughout the presentation into the Q&A tab or the chat tab. It'll be located at the top or the side of your screen, depending on which WebEx system you're using. I really encourage you to use that time. As I said, Eric's a great resource. Try to stump him, ask a question about a particular issue that you're having at your plant, see if we can drill down and find a good solution for you. With that, let's go ahead and get started. I'll pass it over to Eric. I see he's got his webinar screen up, and look forward to the presentation, Eric.
All right, thanks, Ed. Today's topic, Primary and Quality Control Data Integration. My name's Eric Weisbrod. I'm an Engineering Project Manager at Infinity QS. The topics that I'll be discussing today are really applicable to any integration projects. They're not specific to Infinity QS products or Proficient and whatnot. So I'll try to talk in terms of that throughout the duration. Though please forgive me if when I reference the quality system, if I end up referencing it as Proficient or something specific to Infinity QS, I'll do my best to just keep it general because these topics really are just that. Kind of a brief agenda. Four main things that we'll be going through: defining what integration means, the reasons that we typically integrate, considerations to make when deciding to take on these challenges, and then specifically some of the challenges that we run into. And I'll do my best to provide some of the learnings and war stories as they were that I've experienced over the years that I've been working with clients on this. So the first thing, defining integration. It's kind of funny to even have to talk about this, but it's very common for a client to say that integration is important to them or they want to integrate. But depending on the systems they have in place, the culture and expertise they have at the company, integration can mean many different things to many different people. So it's important to really outline the requirements prior to beginning any sort of integration project. And I've kind of broken this down into four examples that I would say generally encapsulate everyone. And these can be mixed and matched within a given deployment. So it's not a one or the other, but you'll go some places and they'll say integration and it means one thing, and go somewhere else and integration means something completely different. So starting first off just with data collection. A lot of folks will say, oh, we want integration. And really what that means is they want data directly from their measurement devices rather than shop floor operators typing in data. So here I've got a CMM, I've got a caliper, I've got a micrometer, maybe I've got a scale. And all I want is for my operator to be able to take a measurement on those things, press a button, and have that data show up in their quality system database. So it speeds up data collection, prevents data entry errors, and really makes sure that we don't get any fat fingering or anything like that. It helps our analysis. So to some folks, when they say integration, it's just purely making collection instruments talk. Next, I'll go on to reporting. So maybe I've got two completely independent systems, and so I want to query both of those systems into one single report. Maybe it's more than just two systems. So here I've got, my quality system database, which I've got labeled as Proficient database, and I've got SAP. And I want some sort of one report that gives me results from both systems that allows me to make decisions. Maybe I've got certain key information in SAP, other key information in my quality system, and I want to marry those two in a completely independent fashion. So this allows users to review the data from multiple systems in one spot, one report. It prevents replicating data, so it's more efficient in that way, and just allows each system to be queried independently. Next, we'll talk about actually transferring data. And this is what I think when most of the time when a client says they want quote-unquote integration is this example. So one primary system directs several other systems. So I've got here my MES or my ERP system, and I want data to go from those systems into my quality system. So it allows the MES or the ERP system to act as the standard or the master and then transfer that information into the quality system database. So maybe I want to create production order numbers or lot numbers or batch numbers or things like that, and that's already handled in one of these other systems. When my operator is entering data, of course I want them to use those same numbers, because otherwise if I have to recreate them in my quality system, maybe it'll get mistyped. So at the end of it all, then my reporting might get confusing if I don't have that exact naming convention the same in both. So this allows that. Another benefit of this is I can then have my experts in my MES and ERP systems remain experts in their own systems, and I can have my experts in my quality systems remain experts in those. Now we have to bridge the gap, and that's always the challenge with integration, what lines up between these systems and how we make that work. But at the end of it, I don't have to have everyone being an expert in every system. I can kind of allow people to focus on their core competencies. And then the last one is true bidirectional communication between these systems. So I've got my same MES and or ERP system, and I've got my quality system, but now I want data to go both ways between those. So a common example might be that production order or lot number. Maybe that gets created in my ERP system, and I want that sent to my quality system. And then when that lot is released for use, I want that status, if it gets released from my ERP system, I want that to make it to my quality system. Data is collected. When I'm done collecting data in my quality system, I want all of the relevant statistics associated with that lot going back over to my ERP system. This is obviously the most challenging type of integration, just because now we have to work with things going both directions, and so there are a lot of challenges along that. So those are the four cases, and we'll talk about some of the challenges and again some of those stories. But the next thing we'll address are the reasons that we want to integrate, because while this seems like a no-brainer, and you know the common conception is, well, geez, I've got this quality system and it's on a computer, and I've got these other systems and they're on a computer. Well, they're both on a computer. Why can't they just talk to each other? So it seems easy, but in order to sell this project, we also need to come up with some tangible results as to why this is going to benefit us, because it's an expenditure not just in terms of, say, software and maybe hardware in terms of servers and such, but there's a significant time aspect involved as well. So one huge reason is just system accessibility. So my stakeholders can't directly access critical data. So here I've got several pieces of equipment out on my shop floor, and the only way for me to get that information is to walk to each and every one of those pieces of equipment and take a look at the little screen that's on there and make my determination as to whether or not things are good. So I'm able to perform my check only after I walk out to all of those. If I could collect that data into a central system, well, now I can utilize that data. I can compare one piece of equipment to another, and I can get that stuff live real time right at my desk. And so a specific example of this, I was at a site where they had their lines monitored for non-compliant product, and they would just kick off bad product into a scrap bin, and those pieces of equipment kept count of how much scrap they had kicked off. And so this example is exactly that. The only way you could understand that was to walk out to each piece of equipment, look at the little HMI, say, okay, I now have this many pieces of scrap generated. I then hit a reset button, so then I know the next time I come, and you just tally it on a notebook, or you take your laptop with you, or what have you. And so then I now have to do that for each individual system and then try and compile that all up into one location. Well, obviously, if I can integrate that and I can just collect directly from those pieces of equipment, I can then just get that directly and generate those reports and know my scrap rates right from my desk. Another big reason is looking at just data versus information. So here's an example of something that I might get out of like a historian system. So it's capturing all the data and stores it for a very limited period of time. And this can be very useful for engineering or maintenance or someone who really knows what's going on with that very specific piece of equipment. But if we just take this information as it stands and we want to start looking at this for statistical analysis and statistical process control to understand the variation of our process, we'll see that the control chart that gets generated and the limits are based on oversaturated data that can't really detect meaningful statistical trends. Right? If we look at this and a control chart where we sample differently, so the same data set sampled every minute versus every hour, we see some very different control charts. So if you notice the difference between the control limits on these charts, on my left chart I can see they're very, very tight. These are actually my control limits, and I'm getting all sort of false signals telling me that I'm out of control, out of control, out of control, out of control, out of control. Well, it's not necessarily due to that data. Here's the same data now sampled every hour, and so my rapid sampling doesn't allow for sufficient process variation, so I'm not getting a true metric of the variation that occurs in my process. And so how do I solve this? I need a sampling strategy that detects the important signals as they happen. So here, changing my sampling strategy from every minute to every hour does that. You know, and some examples I can think of with this, I mean, if I were, let's say, taking a geological study and I wanted to look at a glacier's flow rate, and I say, boy, I'm just starting this. I'd really like to have lots of data for my statistical study to show people that I'm serious about what I'm doing. And so every hour I'm going to measure the location of this glacier. Well, as you can imagine, right, I could after one day say, well, I've got 25 data points. I should start to really understand what my rate of movement is on this glacier. And as you can imagine, glaciers move very, very slow. That's not going to be possible, right? My resolution of the measurement system isn't sufficient to track the actual movement of it. So that's a case of where I need to change my sampling strategy, not just for the process itself, right? Not just for the glacier, but for the measurements that I'm taking. If I've got an automated system here, I can see some kind of cyclic behavior. If I'm truly basing off of these, and you know, someone could say, well, geez, I need to shorten up my control chart time frame. If I look at the data in the very short term and I allow my control limits to move, I'm just going to be following the control algorithm of the piece of equipment. So I don't necessarily know that with this data set, but let's just pretend that these ups and downs are because we're looking at maybe a tank fill volume. And so when it gets to some level, a sensor kicks off and says, oh, I need it to fill up. And then it drains, and says, oh, I need to fill up. I'm actually tracking the control algorithms, you know, instead of the variation of the process. So every data set is different. And so this is an example of oversampled data that has too many false signals. But there are several instances where we really need to evaluate what we're getting and how we can use it for integration purposes. A huge reason for integration is just to reduce labor. Right? A single system eliminates duplicate work. So we don't have to have double entry of things, maintenance of specs, lots, batches, production orders, assignable causes, etc. Again, if I'm transferring that information from one system to another, it allows me to keep them all in their native system. If I've got devices or equipment that I'm collecting information from, well, now my operators can focus on running their processes instead of going to those HMIs, right? So using my caliper scales, etc. It's much faster than typing. I get several benefits out of that allow my operators to really just focus on their piece of equipment, which is why they're actually there, right? I can even remove some checks that operators are performing. If I can get process data from PLCs, that just goes directly into the system without their interaction at all. And then from an analysis standpoint, now I have a single repository where one person can look across multiple, what were previously multiple systems, to arrive at their conclusions. Reduction in cost. So tapping into previously unavailable data gives me visibility to things that I didn't even know before. So I can really maybe learn more about why I'm running into scrap or giveaway. You know, at the site I mentioned previously, just seeing how much scrap I have really allows me to see how I'm doing on a daily, hourly, to-the-minute basis. But beyond that, if I now have visibility to process data that I didn't have before, now all of a sudden I can maybe start to understand, well, why am I generating that scrap? So, you know, SPC is really intended to detect process variation before producing non-compliant products. So here, if I've got the appropriate charts, I can start catching process data before an issue occurs that even leads me to having to scrap product in the first place. And then tracking capabilities. Once I've got this, I can start looking at some simple but meaningful metrics where I can track capabilities to identify where to focus efforts. You know, if I've got two lines that maybe run the same product, or doesn't matter if they're different products, and one of them has a marginal capability, maybe a CP value of 0.8, which means I'm always producing scrap because I just don't have enough capability on that line. And I've got the adjacent line, which has a capability value of 3, which tells me I'm running very well. Well, which line should be a priority in terms of receiving maintenance funding and such? That gives me visibility to which lines need assistance and which ones don't, and ultimately drive my economic decisions based on how my processes are performed. The data quality. So every system that we have to navigate is another opportunity for error. And you know, automated data collection eliminates the human error aspect of it. And sometimes it's due to, you know, Homer's fat fingering that we've got going on. The other things that can happen, though, are just human decision making. So not a keyboard error, but I was at a site one time and we were talking about what will be the assignable causes or actions that operators will take when they run into an error. So I was meeting with the management at the site, and we had come up with a list of these are the corrective actions that will be taken if they find non-compliant product, so out of spec data. And so we come up with our list, and they said, well, let's call in one of our senior operators to just run this list past them and make sure that it's, you know, that we're not way out in left field or they don't have anything to add to it. So they bring in this operator, and they said, hey, you know, what are the typical corrective actions that you might take on a line when you enter out-of-spec values into the quality system? And the operator looked and said, well, I don't put out-of-spec values in the quality system. And everyone looked at each other and said, what do you mean by that? And he said, well, if I get a product and I measure it and it's out of spec, I don't even put that value into the system. I go find another product until I find one that's in spec, and then that's what gets entered into the system. Because they said, well, I know that we don't want to send reports to our customers with non-compliant product on them. So that's why I was doing that. You know, and everyone's eyes got pretty wide in the room. So the operator thought they were helping by not putting in quote unquote bad data, but really they were masking the process behavior that's actually happening. So you might be sending reports saying, this is how well our lines run, and be completely oblivious to how they're actually running. So this helps us get a realistic picture of really what's happening with our process. More on data quality. So some mobile devices and scanners can really help eliminate the transcription errors and combat some of the pencil whipping. So here I've got a mobile device that's got a built-in barcode scanner, so I can scan a barcode by pushing a button. It reads my UPC and it tells me, oh, that product passed. Now I run one that is non-compliant, and I get a very simple go, no-go reading on how that scan did. So this barcode scanner helps me, A, make sure that there are no transcription errors, but now my data are also automatically timestamped for accurate results. If I've got unique usernames and passwords for my folks, which I absolutely should, I get assurance that the right person performed the check, right? It's not someone else's initials that they wrote on the piece of paper. I know because they put in their username and password whether or not they perform the check themselves. And then further, you know, I've been at places where using those barcode scanners on the back of my badge, I could have my username and password embedded into into a barcode itself, and that can speed up data entry or signing into the system as well. And you don't have to use that. I know there are a lot of industries where they say, boy, I really can't do that because what if someone else's badge gets into my hands? I could enter data as that person. That's fine, but those types of things should be, can be considered as solutions to help you out. So now on to the considerations in general for any integration project. It's all about the details. And these of you resonated through these slides, and you'll hear me say it again and again in different ways, but the real trick is to have in-depth discussions up front to prevent surprises later on, to make sure that you understand what the challenges are, what options you've got available to you, and can have some realistic timelines. So just starting out with the technology piece, is it even possible for your existing systems to communicate with other systems? So other databases, so you've got these ERP, MES, LIMS, these other systems that you want to integrate with. Is that database proprietary? Does it allow values to be pushed and pulled from the system? Do you know the schema, the credentials, and where things reside? And a very good example of this, I mentioned ERP, and we get the question time and time again about integration with SAP's ERP system. And, can we integrate with that? And the answer is yes, but SAP is a very large and important system to many companies, and so they don't like external systems just going in and rooting around and pulling data out of the system. So they will push information to an external database, so a third database, and then that's something, for example, then that we could query against that database to get that information. So SAP is happy because they don't have something directly touching them or going in and accessing their system, and you're happy because the results, you're able to get those results out of there. But those are really important steps to understand because you have to have the know-how on how to do that. And so those are the kinds of things you need to understand. Other systems like Proficient, we're a non-proprietary database, so we would allow an external system to come in and query us. That being said, you have to know what you're doing, right? That's not something that can just happen at a whim. And if you go in and don't follow the fundamental constraints of the database, well, then you run into challenges. And so there's that knowledge that needs to be there. In terms of PLCs, most of the time, PLCs are connected through what's called an OPC server. That stands for OLE for process control, and OLE is object linking and embedding. So it's a great abbreviation within an abbreviation. So you may have your PLCs all connected to an OPC server, and that's great. One thing that you'll run into is maybe that OPC server is not on the same network as your quality system. So the quality system is on your business network, and the OPC server is on your production network. How do you bridge that gap? And there are ways to address that, but those are things you need to understand. Flat files. Does the system that you have output to some sort of general text or CSV file, or does it output to some sort of proprietary file? Can that file be saved to a network location, or does it need to be on the C drive of the PC running that? So just understanding these very general rules and these very general questions is very important. In terms of serial, so RS-232 or IP connections over a direct IP address, do you know those connection settings? A lot of times people say, yeah, I can connect that way. Okay, well, what connections what settings do we use? Well, I don't know, right? And it may require expertise from within your site or even from the vendor to understand that and to move forward. And then can the output string be customized? Similar to a flat file, I might get lots of very different output strings. And when you're working through integration, one of the challenges is, can we find enough commonality in the string or the output to be able to get consistent information that can be pulled into the end location? So just because it can connect doesn't necessarily mean that you will connect. And then heck, even with serial connections, do you have the right cables? A lot of people will look and they've got a 9-pin output on the back of their device, and they've got a serial port with 9 pins on it on their PC, and so, well, heck, that should connect. Well, there are a lot of things that can happen with those wires, and manufacturers, for one reason or another, sometimes have proprietary cables. Those sorts of things really need to be understood. In terms of technology, do you have the expertise to do the work that's needed? So for other databases, do you have internal experts who understand the database structure? You're going to need internal experts who understand the business case and the specific information you need, but that's going to even go further to say, well, okay, the database structure both in the source and in the destination, are you able to bridge that gap? Because ideally, your internal experts would be able to handle all of that, but that's often not the case. So can those internal experts write queries, create view tables, reformat data, maybe even generate new fields to provide better understanding to the data that you're getting? PLCs, do you have internal experts who know the location of the tag values and locations? Again, you may have to reach out to the vendor, or if it was set up by a third party, to gain that understanding. Flat files, again, do you know how to configure that output file, the location and format? Sometimes that might even require something like a middleware to figure out. RS-232 and IP, exact same questions. Do you have internal experts who know how to configure and connect and change settings and format? All of those sorts of things are needed for all of these systems. And so integration is, I'll say never. Maybe I could upgrade it to rarely, but I'll say never a case of just plug and play, due to the nature of combining just disparate systems that were independently designed, integrated over time by various people with their various thought processes, and trying to make all of that stuff work. And so the challenge that we have as integrators when we go through these projects is all of that needs to be sorted out. So third-party services. If you don't have the internal expertise, is that something that can be contracted to a third party to work on maybe your database stuff, right? You might say, geez, we don't have the ability to write SQL queries, or we don't have enough expertise. So do you know enough to be able to spec and farm those things out? Same thing with OPC files, right? We may need to create, I'd already mentioned previously, some middleware, or just a change to the way the hardware generates these files or the contents of those. I've been places where I was at a site, I was overseas, it was in Europe, and I probably spent about 3 hours trying to get this Tensor tester to work, and it sure seemed like we were able to get something out, and it turned out that we needed a piece of middleware to de-scramble the information. So we're getting data out, we didn't fully understand it. We finally, after several hours of playing with it, trying various settings, we ended up calling the vendor, and they said, oh yeah, you're not going to be able to just read that in something like Hyperterminal or a generic tool, because we scramble the results. But if you give us a check for X dollars, we'll be happy to provide you with software that does that translation, and then you can do that. And it's like, geez, it was a lesson learned. Big question is has it been done before? Oftentimes, especially on large companies, you may have experts in other divisions or at other sites, people that you don't necessarily know of that may have gone through something very similar or solved these problems before. So I encourage you to really reach out and investigate power users of the various systems to bounce your ideas off of them and make sure they may say, oh, gee, we tried this 3 years ago and our big sticking point was such and such, right? It was maybe permissions or network connectivity or what have you. And at least it can give you a much better jumping off point. So that guidance can really help you from reinventing the wheel. Cost, this is always a fun one. How much is this going to cost? A very complicated thing to arrive at, because we certainly have the cost for the needed software. Some of those systems may be proprietary, but then we get into more of the variable things. We may need custom programming. We may need those third-party sources. So establishing expected benefits is going to, in metrics, is going to help justify that cost. And those detailed conversations that you really need to have up front are going to help with both the time and cost estimate in terms of what's needed. So another question is who can support that integration once it's been completed? So, if custom software has been developed for this, who's going to support that? Training and documentation are a big piece of this. Personnel changes are huge. I can't tell you how many times we go somewhere and we say, well, yeah, this was set up 3 years ago, but the person who set it up left to another position or another company, and I'm inheriting this, and I don't necessarily know why they did what. Having that documentation of why things were done and the decisions made are going to help you maintain consistency and support the system. How to upgrade? This is particularly a concern if you do have any custom work done, because in terms of an add-on solution or off the shelf, that should be compatible with upgrades. But if you've got some truly custom work, that may not be supported as part of your upgrade. So it's important to consider those. All kinds of other things that may be needed are the cables or other hardware, wireless access points and routers, multiplexers. All of these things add expense, and you need an inventory of what all might go into it, and add that in and make sure you've got a contingency for it. Similar to cost, the time is how long will this take? And I'll just tell you, the biggest challenge you will have is you don't know what you don't know. So the more that you know about the systems in advance, the better your time estimate will be. It's very often that you have to put a time estimate together before you really start digging in, and you'll be doing yourself a disservice in doing so. It's really important to learn about the systems before even trying to attempt at estimating time, because you need to be realistic about the time requirements. And one thing that I see a lot are lead times for other resources in other departments. So we start out and we say, yeah, we think this can be done in 6 months. And then you go talk to the owners of that ERP system and say, hey, this is something we want to do, da-da-da-da. And they say, okay, fine. We're swamped right now. We'll be able to look into it in 4 months. Well, now all of a sudden your 6-month plan, because maybe the work you needed to do only takes 6 months, is contingent on those individuals. So identifying the key benefactors also identifies priorities and critical functionality. Another thing that's really important is setting expectations. So when you go to these other departments or other system owners, what exactly do they need to provide? If you go in and say, hey, we want to integrate so that our lots go from the ERP system to my quality system. That's what we want to do. Well, does that include lot status? Does that include status control in terms of release and hold? Where should that be done? Only from the ERP system? Only from the quality system? In both? How often should that be scanned? Do we have rules for lots that have been hanging out there for X amount of time? Really outlining those things is important. And then what contingency plans exist? Because most integration projects take more time than anticipated due to things like, I mentioned, we have this OPC server, but it's on a different network. We thought we understood the schema, but until we really started working it, we didn't know when we ran into some snags. The person we need to work with is on vacation or is on some sort of leave. So then a big question would be, can the implementation be phased in? I'm a huge advocate of starting with a small measured pilot and then growing. So can you focus it on one area, one department, one line, whatever, to allow the technologies to be evaluated on a smaller scale and really help you understand what you're biting off. And I understand this can't always be done, and a lot of times you need capital for everything up front, but it's something that is really worth discussing and pushing for. Benefits. This is a big challenge. Ideally, you'd set expectations for benefits and provide metrics to show those benefits once you've actually performed the integration project. So examples of who might, operators, was time saved, accuracy improved, training simplified. So you can do things with time studies. That can be difficult to do, I understand, and so some of these things are always squishy metrics to provide. But we look at operators. How does that help them? The quality of the data we get. Can our technicians, engineers, managers get better results? Get results to your customers faster. I had one client who quarterly had to generate this massive report. It was unbelievable the amount of information they needed. And they said, okay, I have to do this quarterly. And I mean, it was large enough that it took hours for this one report to generate once we had everything set up. And it says, geez, this is really inconvenient. It takes me hours. And that's a lot of information. I mean, it was tons of stuff. Very, very detailed, sorted in all kinds of crazy ways. And it was like, well, how did you do this before this? And they said, oh, well, it took me at least a week to compile this before. It's like, well, wait a minute. So it took you a full 5 days to do this previously, and now it takes you an hour and a half or 2 hours to compile it. Well, I understand, but, think of all of those time savings, and time saved, heck, walking between those HMIs. Every day I need to walk out and look at those scrap bins. Well, if I just get that stuff instantaneously, how much is that time? I know paper savings is a very popular thing. If we go from a paper-driven system to having everything electronically, I've heard some pretty impressive numbers from clients in terms of paper and ink and such that they're able to save. So just having some of those in your back pocket can help feed things as you go along, because certainly it's a drain on people as these projects carry on and sometimes drag on and stumble. And so having some of these expectations is important. We've got our continuous improvement. Does that visibility help our response time and effectiveness? Are we able to reduce scrap rates? For IT, are there fewer users to support across many systems, right? Maybe I don't have to have as many people going into my ERP system anymore, because now they're able to, I don't need my quality technicians in there. They can just go right into my quality system. And then does high-level reporting allow that data to be accessed directly? So instead of generating additional reports for people, they can just get to it directly. So what kind of challenges do we commonly see in these endeavors? And so again, I'm trying to be very general here and talk about the challenges that we see and then ways we can overcome them. So the scope. Do you know in great detail, notice I've got it underlined, the desired outcome, precisely what you want from this? It's very difficult to go into something with a general knowledge of, oh, we want our checkweighers to send data. Okay, well, how are we going to get the data from those checkweighers? Maybe the checkweighers themselves only send the weight. So do you know in greater detail what's required to make this happen? If I need a weight from a checkweigher, I also need to know what product is going across that checkweigher and what line it comes from. Where are we going to get those from? Oh, geez, I didn't think about that. Well, we're going to need to get the product from our ERP system and the line from our MES system. And I don't know. Right? We need to really outline those things. So providing a mock-up of the expected result is really important, because then you can start to answer those questions. If you look at the mock-up and it says, line 1, product A, weight for my checkweighers, you say, oh, geez, how are we going to get those other fields? So if multiple systems are included, do they, quote unquote, work together? Right? My checkweighers, do they somehow know or talk to my MES or ERP system? I really like planning with a pilot of limited scope, because, again, you can evaluate things on a smaller scale and figure out these stumbling blocks. And as an example, we have a product. It's called Dynamic Scheduler, and it's basically it's a timing clock to tell operators when they need to collect data. So if I have data that has to be collected every 30 minutes or 60 minutes, it tells you when your next collection is due. And we've got some clients that say, hey, I've got systems that know if my line is running or not. So I would like those systems to feed this system and tell it when the operator should begin collecting data. And so we can do that, but then all of a sudden these things come up like, well, what happens if you stop the line for 30 seconds because it gets jammed up and you just need to clear something? So the line goes from running to stopped to running again, but it was only down for 30 seconds. Does that mean my scheduler should stop and then start all over again and treat it the same as my line was down for maintenance? Well, no, of course not. Okay, well, what if it's down for 3 minutes? Well, I don't know, maybe then. We have to start deciding on these thresholds and limits and how we might handle that. Maybe we should put in an operator override. I've seen folks do that, where the system says, hey, this line is now stopped, and something pops up for the operator to say, is the line stopped right now? And they can say yes or no. And if they say yes, then it kills the timer. If they say no, it's just being cleared for debris or something, they say no, and it allows the timer to keep running. How do we address these things? So map out all of the requirements very well in advance, right? That you just need to be as detailed as you can. And it's painful and it's no fun, but it's going to pay out in the end. Identify all the fields that you want to touch in both the source and the quality system, and involve the system owners from the other systems. If you're going to be getting stuff from the checkwares, talk to the people who know the checkwares. If you're going to be getting things from your ERP or MES system, talk to the people who know those systems, because they may be able to tell you about constraints that you never even considered. Data format is a huge challenge. Is the data properly formatted for retrieval? Does it need to be transformed? Are all the fields populated, or maybe there are missing values? How are error values output? Are there conditions that need to be applied to clean up data? So for example, maybe I've got a field that I'm expecting numerical results, and all of a sudden I get text in that field. Well, what am I supposed to do if when there's an error, instead of sending a number, instead of sending a measurement, it sends the word error? Or I've seen systems where I get, nominal values of 10, 15, 20, whatever, and then its error code is it sends out the number 1 million. Well, geez, what do we do if we get that 1 million? Does it need to be, just prevented from coming into the system? Do we have some sort of way of automatically ignoring that? If I get text files, if I have strange headers or inconsistent formatting, again, I may need that programming or middleware to really help drive this. So again, how can we avoid this problem? Get samples up front. Get samples of everything. Every system you're going to get. Find out what does the output look like from this CMM or from this piece of equipment. What do your database queries look like? Perform simple tests to verify that A, you can connect to the system, and B, that the format actually works. And C, involve the system owners. You'll notice that's the exact same one that I have from the previous slide. It's critical to find out, can we change those formats? Is there anything else we can do? Can we get a date timestamp added to that? Can we get them sorted differently? The only way we're going to find those things out is if those system owners and power users are able to get involved. System access itself. Do you have access to the necessary systems in terms of usernames, passwords, etc.? Is the needed data available? Are you able to get in, but you can't actually get the data out? Is it a proprietary system? So all of a sudden we know that we need that third-party intermediate, or all the systems on the same network. All of these things can be avoided by getting samples from all the systems to be used, performing simple tests to verify that connectivity and format, and involving the system owners. So you'll notice involving the system owners has been on every single slide so far. And heck, you'll even notice how to avoid this problem. These 3 bullets are the same as on the previous slide, save for the underline that I added here. So we really need to make sure that we keep everyone involved, and we just perform tests. It just seems like things often slip because you didn't get something up front, and you make decisions based on assumptions, and then 3 months later we find out those assumptions weren't valid. So for best performance and ease of use, it's also easiest when the systems are either on the same servers or in very close proximity, because then you can get away from worrying about cross-network access and things like that. And then finally, expertise. Do you have the know-how to work with the systems, or does it require third-party help? And what's the workload for these resources? So these are huge challenges, and let's take a wild guess as to how we could avoid this. We could get samples from all the systems to be used. We can perform simple tests to verify that connectivity and format, and involve those system owners. Because if you go to internal or third-party resources and ask for help, they're going to be asking some very detailed questions, and they're going to be, basing their decisions on the information that you give them. So you need to provide really specific requirements, and in those examples, again, boy, if you can generate a mock-up in Paint or PowerPoint or Excel or Photoshop, whatever, if you can give them something that says, this is exactly what I'm expecting, that'll go a long way. So my challenge is to you, don't underestimate integration efforts. If it was easy, it would probably be done already at your company. Understand that there are going to be setbacks. So considering contingency plans, including, increasing the time scope, you need to make those considerations from the very onset. Don't keep the system owners in the dark. So just make sure that everyone has a stake in your success, right? They do, and so you need to make sure to keep them involved so that they're well aware of your needs from them and how they can help you with your common goal. Start small and expand in stages. These small examples can really help buy in and prove out that your plans are going to work. And there's nothing more frustrating than spending tons of effort in something and having nothing to show for it. So even those small checks, getting just data from one line or for one specific field can go a long way, which then takes me to feed on your successes. If you start small, you can then show those and showcase that you've got success in your efforts, and that can help keep your project momentum. And my final challenge is, reap the benefits of a successful integration. It's a ton of work, but it is an absolute thing of beauty when it's all set up. If you go into a plant where things are talking to each other and lots get created in one system and then appear on others, and the operators don't have to go in and perform extra steps, and they're able to use their barcode scanners to get things done quickly and efficiently, and your engineers have data to work with, your quality managers can generate meaningful reports for your customers, and your senior management has visibility to things, and notifications are going out, and assignable clauses and corrective actions. All of those things are working together. It's an absolutely beautiful thing. So we've got, as Ed promised, we've got plenty of time for questions. So I'd like to open the floor up for those right now.
Thank you, Eric. Well done. Appreciate it. Yeah, go ahead and ask any questions. We've got both the chat and the Q&A section open, so either or, both will work. There's already been a number of questions coming in, Eric, so I think you'll be excited to dig into some of these issues that the good folks are having. First is coming from Brian, and he's wondering, what is a typical integration time frame?
Okay, so when we think of these projects, think in terms of months. It's not something that typically happens in days or weeks. In terms of properly scoping things out, it's not uncommon for this to be a 2-month, 6-month, 8-month, 12-month sort of process. So just having those expectations up front is good.
Depending on the complexity of all the different systems and whatnot, I take it.
Absolutely, and that's why it's a wide range. But it's one of those things. If you're touching anything else, you're most likely going to need just plenty of time just for the planning aspects and getting everyone aligned on what you're doing. So it's a very holistic process. It's not just the technical piece.
Very good, sir. And this coming from Tim, and he's wondering if the system runs on Citrix. Not necessarily integration, but system question.
Sure. And so the answer to that is yes. There are some things in terms of, again, proximity of servers to each other. And I know in a Citrix environment, there are some aspects to running Windows services and things like that there are some best practices that I'm not personally familiar with, but we in our organization have folks that can answer some of those questions. So the short answer is yes, and I see the response was a good one. There are more details that are specific to precisely what you want to do, but a lot of it comes down to the servers, their proximities to each other, and access to each other.
Got it. And just a side note for everyone, we are going to send out a recording in an email following the presentation, probably by tomorrow afternoon, I'm guessing, but you can look forward to that just to have a record of this. Robert is asking, he's got a good one, if I am sourcing data for Perficient across, say, multiple platforms, would you recommend a middleware solution to consolidate information before bringing it into Perficient? An example we are facing is sourcing data from an ERP, PLCs, PLM, and lab equipment. How should he be approaching this task?
If you've got the ability to put those all into some sort of middleware solution, I would say yes, that is the best approach. And the main reason is there are lots of details that need to be sorted out in terms of what precisely goes with what. So if I get a value from a PLC, how do we know what it should be married with? And lab equipment and so on and so forth. And so it's complex. It's inherent complexity that needs to be sorted out in one way, shape, or form. So you could either put it into a middleware system, and then just using our products, for example, if you're using our data management system, the data management system setup would then be relatively simple because you would already have those things sorted out. If you didn't want to put it into a middleware system, then those complexities have to be addressed by the data management system setup. So depending on your core competencies and who's going to be focused on what, if you've got a strong IT staff, they're probably more comfortable using SQL or Oracle tools or whatever types of tools they're familiar with, rather than making people further experts in, like in our system, for example, or whatever the quality system would be.
I see. Would it work to bring a system integrator in to help out with this issue if it's beyond the scope of your capabilities? Or is that...
Absolutely. So and I'm kind of prefacing this with that you're able to make it work. So I was talking internal resources, but it certainly doesn't have to be, right? It just needs to be anyone that can address your needs. And so that's not uncommon at all. You might say, boy, we do have a strong IT staff, but this specific piece needs to be handled by someone else because we don't know those exact items.
And Eric, Infinity QS has a very extensive partner network that could probably help you out with that. I'm just saying. I don't know if you knew. I just wanted to,
Absolutely, we do.
Very good. Coming from Maria Lucci, she's wondering, what does it take to bring OPC or other databases to the same server that Infinity QS lives on?
So the biggest challenge there is just making sure. So, for example, with our data management system, we can reach out and touch many other types of systems that it needs access to them. So one of the things that is often an impediment is if you need stuff coming from an OPC or another database is from the server that's running our data management system, does it have visibility to the server that's running your OPC server or those other databases? And then what's the network capability between those? So if I've got a cross-network connection that's required, sorry, my slide went away. If I've got a cross-network connection that's required, do I get a latency in those results? So, I mean, it's a common thing for folks to do. You just need to make sure that you're able to bridge those gaps. And there are several ways of doing that. Some of it's just with network permissions. Some of it is, like with our data management system, we have the bridge provider, which allows you to kind of provide access from not connected networks through I believe it's an HTTP connection, but it just becomes more cumbersome.
I see. And we've got a few more questions on deck. I'll make another little side note. Our Crack Infinity QS marketing team is helping us go social, so we've set up a LinkedIn discussion. We'll continue the conversation there. We'll be monitoring it, so if anything comes up later or it might take on a life of its own. This whole conversation could go viral, So we've got our link up right there, but we'll also send that in the email. Coming from Michael, we have about 95% of all of our data now running using DMS and DCS. Thank you much, Michael. The one roadblock I have had is with FoxPro databases. Any idea, any thought about that?
I don't have any specifics on that one. That's something I'd have to follow up with some internal folks on. I don't have direct knowledge on FoxPro specifically, so sorry, but Ed, maybe that's one that we can take as a follow-up point.
Yep, I'm writing it down right now. Michael, we'll be in touch. Thanks for the question, though, good sir. And from Bertram. Bertram is talking about the sheer amount of data and how that can be problematic. He's speaking of collecting 1 gigabyte per day. How do you organize that to archive properly so the online system doesn't slow everything else down in order to achieve analyze the archive data?
So in terms of I guess I would ask. I mean, a gigabyte a day is a phenomenal amount of information. So I would highly encourage sampling the data to I'd have to see the data, but I would think that wouldn't be appropriate from statistical purposes, and so A, that would help there, but B, that's also going to help with amounts of data. In terms of archiving, everyone has, much like integration, different people have very different definitions of what archiving means. And so that's something, there are tools in the database engines themselves in terms of SQL or Oracle or what have you. There are tools available there, and we leave it to the users to determine what's the best strategy and the proper course, because just from a logistical standpoint across industries, companies, departments within companies, and personal opinions, there are a lot of different ways that that can be handled, and so it's beyond the scope of what we can support with a simple off-the-shelf solution.
Understood. And just a few more. I know we're wrapping up. This is from Adrian. Any suggestions on best practices to manage multiple middleware products?
Documentation. making sure that you understand that. One of the things that we run into a lot is understanding the whys of things. So understanding why something was set up a given way, and why decisions were made really help, because you may train someone on something, you set up this middleware, you leave the position, you train your replacement, but it just gets degraded over time, and at some point in the future you might end up saying, geez, well, why don't we do this? I have a great idea. Well, maybe there's a very good reason that was tried originally, and you went around it. So the biggest challenge with middleware is just knowing the source of everything, so the whys, and then also how that can be supported. So just really having those things well documented, because the other thing that happens is maybe the generator of that middleware is gone, and you need to figure out a